Hey guys, welcome to Unit 3. We got triangles today. This is one of my favorite units to teach. It's kind of nice. It's just different. It's not super difficult, and a lot of the concepts are just pretty interesting because we use triangles a lot in everyday life. Okay, so a little background though. Typically, these first few slides we would do in Unit 2, but since we didn't do proofs, we are going to talk about some important properties that are going to affect some of our triangle proofs. Okay, so the first thing is talking about a conditional statement. This is like a logic statement, and you've heard these before. It's an if and then statement, so it's a logical statement that has two parts. Okay, it's a hypothesis and a conclusion. Now, you've heard these words before. You've probably heard the word hypothesis in science class, and then you've heard the word conclusion in English class at like the end of an essay or something. And you've heard that a hypothesis is like an educated guess. So basically, any conditional statement is an if something, so if blank, then, so if something's true, then something else has got to follow. That's kind of the idea. Like, if it is Friday, then I am happy. So the two components are the hypothesis, which is the if, and then the conclusion is the then part. All right, and then some of the logic properties that we talk about are the reflexive property, the symmetric property, and the transitive property. The reflexive property is very important for triangles because what it does is it tells us that one thing is congruent to itself. So like when you hear the word reflexive, you should be thinking reflection, where have I heard that word? Think about looking in a mirror. So if we're talking about segments, it's like saying a segment is congruent to itself. Now it might seem like, oh, why do we have this? It's going to come into play later on. We'll appreciate it, I promise you. And then for angles, it's like saying one angle is congruent to itself. So angle A is congruent to angle A. It's like looking in a mirror. We see the exact same thing on both sides. Then the symmetric property is a little bit different. When you have something that is symmetrical, it's something that can be divided, like cut down somewhere into two congruent parts. So I always think of a butterfly when I think of something symmetrical. You can fold a butterfly in half and its wings will overlap perfectly. So this one looks like this. If AB is congruent to BC, we're talking about segments here, then BC is congruent to AB. Basically what it does is it lets us change the order of the statements. And this is important with proofs because a lot of the times we have to look at something and then we have to be able to look at it backwards. I know that might not sound very explanatory or a good explanation because we haven't done proofs yet, but again, these are for proofs. They'll become more clear once we get to use them inside of proofs. So then we have if angle A is congruent to angle B, then angle B is congruent to angle A. Okay, and again, just switching the order of those. Now, lastly is the transitive property. This one's usually the easiest to remember. And I'm sure I will do a birthday example once we get into class, or an age example. So this one is if AB is congruent to BC, and I'm going to run out of room on this one, BC is congruent to CD, then AB is congruent to CD. So what this one does is we start with one thing. So we know that AB is our first segment, and then we know it has to be congruent to another. But then if we know that second segment is congruent to a third segment, we can conclude that the first and third segments have to be equal to each other. So it's connecting three things that are congruent and relating the first one back to the third one. So same thing with angles. If angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. So we use B to find that relationship between A and C. So let's do a little practice here. Which property is illustrated in each example? So the first one, if NK is congruent to BD, then BD is congruent to NK. So we switch the order of them, and there's only two of them, so we conclude that it's got to be the symmetric property. Okay. Next, if R is congruent to angle T, and angle T is congruent to angle P, then angle R is congruent to angle P. So this one, we're connecting three things. This is our first, second, and then we're connecting second to third, and now we're connecting first to third. So it's, like I said, we're connecting the very first thing to the third thing that we talk about. So this is that transitive property. Then we have FG is congruent to FG. Whenever something is congruent to itself, we say that's the reflexive property. Think of it like looking in a mirror. You see yourself. Next one, if AB is congruent to BC, BC is congruent to CD, AB is congruent to CD. We connect the first thing back to the third thing. That's the transitive. And the last one, if X is congruent to Y, then Y is congruent to X. And that's that symmetric property where we can change the order. All right, so that's a little background knowledge on just some of those properties. We'll go over those later on. But now we're actually getting into the triangle part. So the first part is pretty straightforward. Triangles and triangle sum properties. So this is something you probably already know, but it's very important. And if you learn anything from me this year, I hope this is it. The angles of a triangle always have a sum of 180 degrees, that magic number we love to use. So triangles are named using three vertices. We either use the word triangle and then ABC, which are the 3 points, or we use the triangle symbol, which is a triangle, ABC right next to it. Continuing on here. So the sum of the measures of the interior angle is 180 degrees. That's an important theorem for any triangle. Okay, so we always assume that regardless of the form of the triangle, whatever type it is, it's always going to add to 180 degrees for the interior angles. So these three here have to add up. Okay, so what that does is for a problem like this where we have to solve for x, we just can add every little piece together. So I'm going to add the measure of angle P plus the measure of angle Q plus the measure of angle R. All together, they need to equal 180. So what I'm going to do is I'm just going to replace these with what their angle measures are. So we get 2x minus 20 plus 95 plus x equals 180. We just got to combine our like terms. So 2x and x gives us 3x. Negative 20 and 95 gives us plus 75. Then we got to subtract 75. We get 3x equals 105 and divide by 3, and we should get x equals 35. And we can plug it back in there to check it out, but it should work. Now on to the last slide here. This is one we'll again do more practice with, but so classifying triangles. There's two different ways. We can either classify by angles or by sides. So the angle measures, if we have 3 acute angles, which means they're all less than 90, we call that an acute triangle. If we have 1 right angle, we call that a right triangle. This is the most important one because we're going to work with this one throughout the year. We have some concepts later on. An obtuse angle, which is greater than 90, is called an obtuse triangle. It can only have one obtuse angle. And then when we have three congruent angles, that is called an equiangular triangle, if we know all of the angles are congruent. Then we have by side lengths. So if we don't have any congruent sides, that is called a scalene triangle, where every side has a different value. Then there is isosceles. If we have two sides that are congruent, at least two sides, and then if all three are congruent, that is called an equilateral triangle. All right, so go ahead, do the practice problems that follow this,